All right, guys, welcome back to aud205. This is class 3. We're going to be continuing on with our noise reduction and cleanup projects. So we're going to import our OMF file from class 1. Goodbye. All right, I'm going to show you the adaptive noise removal plugin that's built into Audition. This is kind of a quick and easy way to get some pretty good results pretty quickly. To get some pretty decent results, actually. The adaptive noise reduction plugin. And it's going to tell you it's a CPU intensive plugin, which is fine. It makes a little red background on the plugin here to let you know, and we don't have to see this again. This is the default, and how this ends up working is it records in a little bit of the background noise, and then over time it adapts to the noise that it's hearing. So if I play over this,
hey guys,
you see it takes a few seconds for it to clean up. So a way to get your project clean from the very beginning is to, if you have some of the noise from this file, in this case, this is our noise here. We just want enough so that it starts working before our first clip here. So, okay, so I think we're good there. We just need to get our... So what we're going to end up doing is dropping down our automation track, and we're going to do show envelope and then volume. And then what this does is it takes the output of the plugin. So since this is an insert plugin, it's taking the output of the plugin and adjusting its volume. So this is post plugin volume adjustment, and our first frame is at 5 seconds. So we're going to go to there. We're going to set a keyframe. I'm actually going to fade in a little bit here over time, and then drop that out. So now when we play over this, it should be quiet up until we start.
hey guys,
You can actually see what's happening over here in this input and output here. It's actually, the plugin is getting the sound,
hey guys,
and then it's starting to do its work. So there are a couple parameters in here that I like to start off with. This is another case where each situation is going to be a little different, and you'll have to work some of the settings in order to get the results that you want. In this case, I start with the presets, and so all plugins come with presets, and they're basically just parameters that are saved into something. So heavy noise reduction is going to have a much deeper dig. It's going to have a 24 dB dig, and then it's going to say the noisiness level is a lot higher. So I think the light noise reduction is a pretty decent starting place, especially in this case. Adobe did a pretty good job of coming up with a basic setup that works really well. For these first clips, I don't know that I would change much at all, to be honest with you. We'll play across it and see if we hear anything that stands out.
hey guys, where's Brooks?
Okay, so you obviously heard a couple of times when the plugin started working again. To mitigate that, we need to set up our crossfades. So in this case, we're going to extend out the front, extend out the tails, and then bridge the gap here. I'll probably just fade this out. Okay, so let's play across it one more time.
hey guys, where's Brooks?
Yeah, that's great. I think the
Where's Brooks?
that's great. I think I might just tone this back a little bit here. Maybe do about 8 dB of reduction. And then a trick, I think that works pretty well actually, is to do a second adaptive noise reduction back to back, set it to light again, and then maybe set this one to 6 or so. So then you actually get double reduction across the whole thing. And so the first plugin then feeds into the second one, and the second one does a little bit better. So here's playback.
hey guys, where's Brooks?
And I think that's really good. Now what do we do about our second set here? So we know that we need the crossfades to sound decent. So I'm going to bypass the plugins while I work on the crossfades because you want the noise level to stay pretty smooth across the transitions.
That, well, are just too good to pass up.
Brooks got one of those.
So we're going to... And volume matching is pretty important too.
Good to pass up.
Brooks got one of.
Wow.
Isn't that wonderful?
Wow.
Wonderful.
Wow. But where did he go?
He's in a much better...
But where did he go?
He's in a much better place now.
Heaven?
So this just takes a sec.
Heaven?
Even though we're happy.
I see.
Even though we're happy.
I see.
Even though we're happy.
I see.
Even though we're happy for...
All right, and the last clip.
Just think about all the good times we had.
Yeah. The good times.
Okay, so let's see how this sounds without changing anything.
You see, champ, sometimes in life, opportunities come by that, well, are just too good to pass up.
Brooks got one of those opportunities and he took it. He's going to be a musician. Isn't that wonderful?
Wow. But where did he go?
So actually pretty impressive, I think. I'm going to pull the head of this clip out so there's a little bit more room, and we're going to do our little volume trick here again. We don't need a fade in because we'll achieve that through the envelope down here.
You see, champ, sometimes in life, opportunities come by that, well, are just too good to pass up.
Brooks got one of those opportunities and he took it. He's going to be a musician. Isn't that wonderful?
Wow. But where did he go?
He's in a much better place now.
Heaven?
No, Minnesota.
Oh. But does that mean he won't be a hootenanny anymore?
We're afraid so.
Oh. I see.
Even though we're happy for Brooks, it's okay to be sad.
Just think about all the good times we had.
Yeah. The good times.
So as you can tell, it does a really good job. However, I don't think it does as good of a job as the waveform noise reduction that we did last week, but it also took far less time to achieve this. So let's go over a few of these settings to get a better understanding about this. The reduced noise by is the gain in which it's going to turn the noise down, as you would probably expect. The noisiness indicates the percentage of original audio that contains noise. So in the case of this clip here, where it's pretty high, so if we turn this up to say 35%.
You see, champ, sometimes in life, opportunities come by that, well, are just too good to pass up.
Brooks got one of those opportunities and he took it. He's going to be a musician. Isn't that wonderful?
Wow. But where did he go?
He's in a much better place now.
Heaven?
No, Minnesota.
Yeah, so I think adding a few extra percents to the noisiness kind of helped clean up a little bit more of that. This is definitely a plugin where you can push it a little too far very quickly. But yeah, just listen to what it's doing, and you can always drop the reduced noise by down to 0 and then walk it in until you think it sounds good. Fine-tune noise floor. Manually adjust the noise floor above or below the automatically calculated noise floor. And then signal threshold. Manually adjust the threshold of the desired audio above or below the automatically calculated threshold. So this is telling the plugin where the signal is, and this is that you want to keep, and then this is telling the plugin where the noise is. So in relation to the noise, anything above this point is going to work harder. Anything below is going to be more relaxed. So then also, as far as the signal strength goes, anything below this point is going to be more relaxed, and anything above this is going to work harder. The spectral decay rate determines how quickly noise processing drops by 60 decibels. So fine-tuning this setting allows greater noise reduction with fewer artifacts. Values that are too short create a bubbly sound. Values that are too long create a reverb effect. The broadband perspective retains desirable audio in specified frequency bands between found artifacts. A setting of 100, for example, ensures that no audio is removed 100 hertz above or below the found artifacts. So it's going to find a noise print frequency-wise and say that noise print is from 50 hertz to 150 hertz. Well, if you set this to 100, then it's going to find everything from 0 hertz to 250 hertz. It's going to create a boundary above and below the range that it finds. The FFT size determines how many individual frequency bands are analyzed. Choose a higher setting to increase frequency resolution. Choose a lower setting to increase time resolution. High settings work well for artifacts of long duration, like squeaks or power hum lines. Low settings better address transient artifacts like clicks and pops. The high quality mode performs slower processing but achieves superior results. So in this case, if we turn it on, we should...
You see, champ, sometimes in life, opportunities come by that, well, are just too good to pass up.
Brooks got one of those opportunities and he took it. He's going to be a musician. Isn't that wonderful?
Wow. But where did he go?
He's in a much better place now.
Heaven?
No, Minnesota.
Oh. But does that mean he won't be a hootenanny anymore?
We're afraid so.
Oh. I see.
All right, so that's adaptive noise reduction. Just play over the front bits again.
Hey guys. Where's Brooks?
All right, so we're going to take a look at some other things. Let's go back to our project here. I'm including with this class a test file for you guys to work with. We're going to call this the aud205 class 3 noises. And if you double click on this, it's going to load into the waveform editor. So we have several samples here of what some different noises that we have. The first one is 60 cycle hum. 60 cycle hum test. And we have hardware electronic background noise. Electronic background noise. And we have crackling. This is crackle. And we have distortion. This might be a little loud. Actually, let me turn it down a little bit. Distorted microphone. Distortion. Distortion. Feedback. So this is feedback in the audio. Feedback. And then this is clicks and pops. Clicks. Which is disgusting. Okay, so the first one we want to look at is the hum. So this is a pretty brutal example of this. So the dehummer has harmonic intervals. So you have the root and then the first harmonic, second harmonic, third harmonic for the 60 cycle tone. I find that the Q is a little loose on this because you're going to lose a little bit of the voice. 60 cycle hum test. So we definitely got rid of the hum, or at least the bottom side of it. 60 cycle hum test. We just have a few more harmonics past this 8 value. What we can do is we can fine tune this up a little bit. 60 cycle hum test. So 60 cycle hum test. Cycle hum test. So it's not bad. So it's isolating the hum frequencies and then removing it. We still have several to deal with up top here. So you can apply, that reduces it down. Now to get the rest of it out, we can go into our noise reduction restoration, capture this noise print, just reset this back to default, capture the noise print, go to logarithmic. So that's clearly where our peaks are right here. So now we do the whole thing. I need to close out. So 60 cycle hum test. So I'm going to crank up that precision factor again. "60 cycle hum test." Just a little bit more of this. I think we're in really good shape. 60 cycle hum test. So give that a listen. 60 cycle hum test. Some residual artifacts from our dehummer. So I'm going to go back to the dehummer and see if I can clean that up before I do that. So 60 cycle hum test. "60 cycle hum test." 60 cycle hum test. "60 cycle hum test." All right, so that sounds pretty good. I'm gonna 60 cycle hum test. Great. I think that sounds pretty good. And then we'll get the rest with the noise reduction plug-in here. Noise reduction process. We're gonna capture the noise print and look at the whole thing. 60 cycle hum test. Right. 60 cycle hum test. So we're a whole lot better than we were. So I think this is pretty decent. 60 cycle hum test. There's some kind of weird stuff, but you can edit that out if you need to. So just can clean up some of those residual artifacts manually. 60 cycle hum test. I think the voice itself sounds pretty good. In this case, for the electronic noise, so we'll actually go back to our old friend here, the noise reduction restoration plugin, and capture in this noise print, and then see how this goes. Electron. So that sounds pretty good. So we'll highlight the range. Give that a little play. Electronic background noise. Feel like we're working a little hard on this guy. Electronic background noise. Crank that up a little bit. Electronic background noise. Yeah. All right, so I'm gonna set this to 70 and this to 15. We'll see how this sounds. Electronic background noise. It looks like I have to turn this up a little bit more. Go to 19. Electronic background noise. So I'm going to apply this. Now we have electronic background noise. So the next one in your file is crackle, but we're going to skip over that for the moment. So we're going to move on to feedback. What do you do about feedback? And this is where the spectral tool comes pretty handy. So there's we have a high frequency and a low frequency ring in this one. Feedback. So what you can do is you can draw a box around this guy, and then there's a auto heal selection. If you right click on it, and that's going to process, and then it's going to take it out. Feedback. So we have a few little guys over here that we'll take out. Auto heal. Feedback. All right. So there's 3 different tools here that do the exact same thing. So you have the marquee, which is the square. You have the lasso if you need to come in and draw a line around this whole thing. You can use a lasso. You can use the paintbrush if you want to be, this is more and then this is less kind of thing. So we'll do that. And then you right click in here and say auto heal. The Band-Aid is for spot healing, so you can tell it, okay, if you click and hold this whole area, and then as soon as you let go, it's going to auto heal it for you. So that's a little quicker. Let's see how those sounded, because feedback. Yeah, we still have some. So what I'm going to do is just draw a box around this, and I'm actually going to just use the gain adjustment and crank that down some. Do a little bit more. So feedback. Pretty close. Drop this guy down. Feedback. Feedback. Not too bad, actually. Especially considering a couple years ago we wouldn't have been able to do this. So, all right. Feedback. Or we would have had to do it with an equalizer and find this exact frequency that we're cutting out. The last one is declicking, and I apologize for how nasty this sounds. Highlight the range, go to effects, restoration, go to automatic click remover. So there's light, medium, and heavy reduction presets. I tend to go straight to heavy and then even crank it up even further to try and get this plugin to work. So we're going to play across these and see if I'll just turn this on and off to see how much it's doing. Clicks. So it's really only softening them a little bit. And so I'm going to segue into a third-party set of plugins. So under restoration here, I have the iZotope RX bundle, and they have a declicker in here. There's a couple different algorithms: single band, periodic, and random clicks. This is a random click, and then sensitivity. At 1, it's not going to do anything, but then you crank it up to a 10, and it should get rid of a few of these at least. Clicks. So again, it's softening them. This is, like I said, it's an exaggerated case, but where you might get a couple mouth clicks from a section like here. Clicks. When it's turned off, you're going to hear them. Clicks. Clicks. And if nothing else, you can always delete them, but sometimes they're in the middle of words, so this does a pretty good job of getting them out. Another handy trick is to just give your talent an apple or apple juice to dry out their mouth when they're talking. So in this case, we'll just highlight this and hit apply. It takes a couple seconds, but then we got... you can even run it past it a second time to see if that helps at all. Where's that? Restoration declicker. Here we go. Clicks. Yeah. So we're getting a little artifacty, but it's definitely better than where it was. Clicks. It also softens the transients in the voice too, so just be careful that you don't push it too hard and you lose the k and click. Clicks. Okay, so now we got a couple things left. The decrackle we'll come back to now. So the iZotope bundle also has a decrackle plugin. iZotope decrackler. I'll play across this. This is Crackle. So the skew adjusts the strength versus how how much crackle is in the signal. We have a lot of crackle in the signal, so a skew of 10 is basically not going to, it's not working very hard at all. So if I turn this on and off as it goes, this is crackle, and then as it goes down, it starts digging more into the file. This is crackle. This is crackle. So we're getting some artifacts, obviously. So I'm going to back this down just a hair, but I think that's pretty usable. You can turn up the quality here for when you render out. And then we're going to go into noise reduction. Now, the isotope bundle also has a noise reduction, a denoiser. So in the basic sense, you, instead of capturing a noise print, you tell it to learn. And then I have this range selected, so I can now play it into the, once learn is on. So we have our, now we have our print. So now we go to play back the whole thing. This is crackle. We could probably reduce a little bit more. This is crackle. So then when you go to advanced, there's a few more options for you. One is artifact control global smoothing. So there's, turn this up a little bit. And then there's, they have tonal and they have broadband. Tonal is, you know, if you got a car coming up with a drone, you know, kind of a, then tonal is going to go after that, or if it's feedback related. Broadband is more like our just normal noise that we've been going after all along. So here, let's see how this sounds. This is crackle. So we can maybe drop this down a little bit more. This is crackle. All right, so I think we're in okay shape here. This is crackle. We're softening it up a little bit. And these are, again, extreme cases, so to show you. This is crackle. Just the differences. And then last but certainly not least is the distortion. So what do you do about distortion? Distorted microphone. Distortion. Distortion. All right, so we have some pretty strong squared off waves. So I'm going to first start out by lowering this down 6 dB so we can see this. So then under the isotope bundle, there's also the declipper. And what the declipper does is redraws these peaks back. So I dropped it down 6 dB so I know that they're hitting at 0 or they're hitting at -6 right now. So I'm going to set the threshold just below that. So if you play this back. Distorted microphone. You can see it. Distortion. Distortion. So what you want to do is you want to set your clipping threshold just below distort where it's actually hitting. In this case, it's going to be -7 because we're clipping at -6. And then our makeup gain, you want to make sure that you're not peaking on the output. Distorted microphone. Distortion. Distortion. So yeah, it does a really good job. We're going to apply that. Now we got our peaks back. And our distortion is gone. Distorted microphone. Distortion. Distortion. So this last one, distortion. There's still a little something in there that I'm not thrilled about. So what you can do is you can go into, so I'm going to highlight this range, go under effects, and then there's a reverse. Now, this is a little trick I picked up. If you go into your decrackler plugin, you want to process distortion backwards with decrackler. It does a really good job, actually. So here it comes. So now I'm going to apply this. And I'm going to flip it backwards again. So, distortion. So that cleans it up just a little bit more. Something about the decrackle algorithm when it's looking at distortion in reverse looks like crackle. So that may help you out as well. If we go back to our original audio here and just did only that, I can show you what that sounds like. So decrackler. So it's also going to redraw the waveform. And then reverse this back. Distorted microphone. Distortion. Distortion. So it didn't clean up this bit nearly as well as our declipper did, but these two guys came back sounding pretty decent after just the reverse decrackle. I think that's it. So go ahead and play around with this file. These are kind of extreme cases, worst case scenarios again, but gives you something to play around with and work on. Next week, we're going to tackle some voiceover cleanup and mixing, also a little bit of music editing, and we'll talk about music licensing as well. As always, if you guys have any questions, feel free to hit me up in the forums, and I hope to see you guys next week. Take care. Bye-bye.